Welcome to the Richardson RFPD Tech Chat. Today we're going to look more at LiCAP retrofit reliability. I have with me today Marty Mills, the Director of Sales for North America LiCAP. And my name is Chuck Cook. I'm Senior Application Engineer at Richardson RFPD. The last time we talked, Marty, we were talking about the need for the pit system and power backup, and I thought maybe we could just very quickly review that. This is the 2020 data for the 5 top manufacturers of wind turbines and their installations last year. The top 5 are Vestas, GE, Goldwind, Envision, and Siemens. And when you look at those systems, 39% of those manufacturers are using hydraulics for their pitch control system, and 61% are using electrical systems. And of those, Ultracaps are in 40% of the initially manufactured systems, and 22% are using batteries. And those are primarily the GE systems. So what we talked about was LiCAP's retrofit solution to replace batteries as the power backup. So welcome, Marty. How about we start our discussion today with some overview of the system?
Yeah, thanks, Chuck. It's great to be here today with you to talk more about LiCAP's retrofit product. Remember, the LiCAP product consists of everything needed to replace the battery, energy storage, charger, and communication systems in GE 20 Newton meter and 30 Newton meter ESS and MSS turbine models. This kit consists of 4 or 6 ultracapacitor modules, a centralized charger, a communications unit, the necessary wiring, brackets, and other hardware. It's a drop-in replacement. Shown here in this slide are the components and a photo of an installed system in a 30 Newton meter ESS model GE turbine. Ultracapacitors make a more reliable alternative to batteries because they have much longer life than batteries, approximately 10 to 15 years, compared to 3 to 5 for batteries. They also have a gradual aging profile, which is very predictable, as opposed to the sometimes abrupt failure of batteries. Ultracapacitors have a broader temperature range than batteries, a range of -40 to +65 degrees C. This is a big plus in colder climates as well as hotter areas, and ultracapacitors can cycle up to 1 million times. Compare this then to the limited life cycle of batteries. They're lighter weight, they do not contain any lead or acid, and they can be fully discharged, making them safer than batteries. The result is a lower operating cost for the wind farm. They do have a higher initial cost, but the payback is typically 2 to 3 years.
That certainly looks good, Marty. Could we talk in more detail about the cell design and construction features that contribute to such a long life expectancy?
Yeah, certainly, Chuck. Let's start with the construction of the cells. Shown here is an exploded view of the cell design. The major cell parts are made of aluminum. Aluminum is used for its conductivity and strength, and its neutrality to the electrolyte and electrical ion storage process. The cell is totally sealed using O-ring and crimp seals. Electrical connections are all laser welded between the electrode, the collectors, and the cell. The can itself is positive and separated from the negative terminal of the lid by an insulating ring. The can is also has an insulating sleeve cover and a machine safety pressure relief feature in case of abusive conditions occur, such as over voltage or over temperature. Now let's talk about the electrode itself. LiCAP uses a patented activated dry electrode for its cells. LiCAP's president and founder has been granted 2 patents for the electrode for the activated dry process. LiCAP's electrode is activated, which enables us to use less binder in the electrode and results in lower equivalent series resistance, or ESR, as the binder is non-conductive. Using less binder also results in the ability to have more activated carbon in the mixture, allowing higher capacitance in the same volume, a performance advantage. And here, there are other significant advantages to the dry process as well. The dry process has a smaller factory footprint because ovens aren't needed, and the overall process uses less power. Slurry-based processes need the ovens to remove the solvents, and of course the ovens require a lot of power. The result is an overall lower cost process. The dry process electrode also has shown to be more durable with less flaking, peeling, and cracking as compared to electrode made from a slurry-based process. The result is a higher reliable electrode with better electrical performance.
Marty, aren't there other factors that contribute to the life expectancy of an ultracap, like the system voltage and overall operating temperature of the environment?
Yeah, that's a good question, Chuck. The LiCAP system has been designed with this in mind. The system has been planned for long cell life. The system uses 6 modules with 6 cells in each module. That's a total of 36 cells in the system. The system's charge voltage is 86.6 volts. That's a planned voltage of 2.4 volts per cell. Shown here is a typical mean service life versus temperature graph for ultracapacitors at 2.4 volts. Based on average operating temperatures below 35 degrees C, taking into account the seasons and night and day variations, the system is designed for 15 plus years of service.
How about the module itself, Marty? Are there other important design features that should be considered?
Yes, absolutely, Chuck. The LiCAP modules have welded cell packs and are fully enclosed. The aluminum bus bars connecting the individual cells in the module are laser welded to ensure robust, reliable connections for the life of the installations. Compared to using threaded cells with nuts, laser welded busbar cell connections maintain constant contact resistance. Threaded cells can loosen over time or be over-torqued, contributing to higher contact resistance, which can then lead to increased temperatures that can shorten life and contribute to module failure. In addition, LiCAP modules are fully enclosed and IP20 rated. This makes them easy to transport and install without worry of damaging them in the process. We have also included tie-down features to attach wiring harnesses to each module.
Wow, Marty, system really looks impressive. A lot of well-designed features contributing to the overall reliability. We're kind of out of time today, but I wanted to thank you very much for taking time with me and really appreciate it.
Makes sense, Chuck. Thanks for having me today, and I'll look forward to our next chat.
Thanks, Marty. Bye-bye.
Bye.